Hey math enthusiasts, I'm here to finish up the notes on perimeter, circumference, and area. So, for this first problem, we're told that Sam can mow 600 square feet of grass in 10 minutes. And then we want to figure out how long it would take him to mow the grass of a rectangular field that is 20 yards by 28 yards. First, let's start with that given information. So he can mow 600 square feet, or feet squared, in 10 minutes. Now I'm running into a little problem down here in the second part of the problem because now they're using yards. So now I want to think about converting this 600 feet squared into yards to figure out how many yards squared he can mow in the 10 minutes. Well, from the previous problem, we discovered that 1 yard squared is equal to 9 feet squared. So from here, I can try to convert that. So we have 9 feet squared to 1 yard squared. And they're telling me he can mow 600 feet squared. And I'm trying to figure out what that's going to be in yards squared. So once I have my proportions set up, we can cross multiply and solve. I'm going to end up with 9x equals 600. And then x equals 66.7 yards squared. So now that we have our conversion, let's focus on the second part of my problem. So now for the second part of the problem, I'm focused on this rectangular field that has a width of 20 yards and a length of 28 yards. Next thing I want to think about is what is the area of that field. When I multiply the length by the width, I get 560. And since it's area, it's going to be yards squared. Now, based on what I found earlier, I know that he can mow 66.7 yards squared in 10 minutes. But now the field we're dealing with is 560 yards squared. So what I'm trying to figure out now is how many minutes is that going to take? So similar to the last problem, I'm going to set up a proportion and use that to help me solve. Now after I cross multiply, it's going to end up being 66.7. X equals 5,600. And after I divide, I end up with 84. And the units I'm using here are minutes. Now, for the second part of the question, they want to know if the lawn was twice as long and twice as wide, would it take Sam twice as long to mow? So, we can work through the math. We'll expand the lawn, and instead of 20 by 28, now let's say it's 40 by 56 yards. So we can do the same thing. We can figure out our area, which is 2,240 yards squared. And I can go through and solve this the same way. So we'll use our conversion earlier. 66.7 yards squared is going to take 10 minutes to mow. So now what I want to figure out is how long is it going to take to mow 2,240 yards squared. So let's fill in x for minutes because that's what I'm trying to solve for. So we'll start off the same way. My equation is going to look very similar to the previous one, 66.7x, but now it's going to be equal to 22,400. And x is going to equal 335.8 minutes. So that's how long it would take to mow that new lawn, which is obviously more than double my original answer of 84. So the answer is no. Now I want to take another look at solving this problem without having to go through all the math. Now let's start off and think about our original lawn that we had to mow. So if you remember, that was 20 by 28 yards. Now in this case, it took me 84 minutes to mow this section right here. Now for the second part of the problem, they doubled my width and they doubled my length. Now when I enclose this lawn, which is 40 by 56 yards, I can really compare it to my original, and I can start to see that I can really divide my new lawn into 4 equal sections. Well, if it took him 84 minutes to mow the first piece, it's going to take him 84 minutes to mow the next equal section, 84 minutes for the one after that, 84 minutes for the one after that. And after I add up those 4 sections, it's going to take a total of 336 minutes, which I can see is not twice as long, but is really 4 times as long. Now, for this next problem, they give me the area of my circle, 12 pi meters squared, and I'm trying to figure out what the diameter is. So let's start with the area of a circle. I remember from my notes that the formula for the area of a circle is pi r squared. Now, in this case, I am looking for the diameter, but if I can figure out what the radius is, I can easily get the diameter. So let's fill in what we know. They give me my area, which is 16 pi. And I know that's equal to pi r squared. So let's start off by getting rid of pi on both sides. Now those are going to cancel out, and I'm going to be left with 16 equals my radius squared. Well, to get r by itself, I just need to take the square root on both sides, and my radius is going to equal positive 4. Now, what they were actually asking for was the diameter. I know the diameter is really equal to double the radius, so in this case my diameter is 8. And the units they were using were meters. Now, for the last couple problems, I need to graph the points, figure out my perimeter and area of each of these figures. Now I've plotted my 4 points, and we have 2 options to figure out the length of each side. We can either use the distance formula and the coordinates they give me, A, B, C, D, or since it's already on the graph, I could try to form some right triangles and use the Pythagorean Theorem. And I think the Pythagorean Theorem is going to be a little bit easier. So let's start with AD in the bottom right. So I essentially want to map out the slope of that segment. It looks like it's going 3 units down and 4 units right. Now what I'm trying to figure out is, alright, well, if the height is 3 and the base is 4, how long is the hypotenuse? Well, in this case, if I use the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, I can solve for that. So I'm going to end up with 25 equals c squared, and it looks like c is equal to 5. So now I have my first length. Now, if you notice, that is actually a Pythagorean triple. So if you saw that it was going to be a 3, 4, 5 initially, you could have skipped over the math and just jotted down 5 for your third side length. Next one I'm going to move to is BC up top. Now I notice when I map out the slope here, I'm going 3 units down and 4 units right or left, depending on which way you're looking at it. Now, what's going to happen when I sketch out this right triangle is it's pretty much going to have the same setup as the first one that I just worked through. So my work is actually going to be the same in this case, and I'm going to find that not only is AD 5, but BC is also 5. Now let's see if we can find our other two lengths. So I'll move on to AB. So I'll go all the way up until I get to where B is, and all the way right until I get to that point. And it looks like I went up 8 units and right 6 units. So we can sketch out our right triangle on the side. We have 8 for our height, 6 for our base, and once again, I'm using the Pythagorean theorem to solve for my hypotenuse. 6 and 8 are my legs, and I'm looking for C. Well, it looks like we're going to end up with 100 equals C squared. So in this case, C is going to be 10. So now I have another length, AB, which is 10. Now, when I go to sketch out my other right triangle for DC, I'm going to find that the two side lengths are once again 8 and 6. So I'm going to end up with the same exact right triangle that I had for my other problem. So now I know the length of CD is also going to equal 10. So in this case, my opposite sides are congruent. So at the very least, I'm looking at a parallelogram. Now I can answer the question they're asking. First, for my perimeter. So my perimeter is going to be the sum of all 4 sides. So 5 plus 10 plus 5 plus 10. So it looks like my perimeter is going to be 30. And in this case, they don't give me any specific units, so I'm just going to put down the units. As for my area, well, it does appear to be a quadrilateral. All right, and in this case, I could go through and prove that all of these are right angles by showing that their slopes are opposite reciprocals. So in that case, what I'm actually looking at is a rectangle. Well, I know my formula for the area of a rectangle is going to be length times width. So in this case, it's going to be 5 times 10. So my area is going to be 50 units squared. Now, for our last problem, number 13, let's start off by plotting our 3 points. Now, in order to find the perimeter of this triangle, I'm going to need to go through and find all 3 side lengths. And I'm actually going to start with HK, just because that's a vertical segment on my graph, and I can count those spaces. It looks like HK is 6 units. Now, I'm going to use the same method that I used for number 12 for this problem. So instead of using the distance formula, which I could do with the coordinates, I'm going to go through and sketch some right triangles. So from H to J, it looks like I'm going 5 units to the right and 2 units down. So for this right triangle, we have 5 for the base, 2 for the height, if you want to look at it like that. So when I plug it into the Pythagorean theorem, 2 and 5 are my legs, and I'm looking to solve for the hypotenuse. Now, for number 12, I ended up with the Pythagorean triples. It doesn't look like that's going to happen in this case. So after I take the square root of c squared, I'm going to end up with the square root of 29. So for HJ, we have square root of 29. The next one I'm looking for is KJ. So we'll sketch out that right triangle. And now it looks like my units are 5 and 4 that make up the legs on that right triangle. So we'll sketch that one off to the side. 5 for my base, 4 for my height. Once again, those are my two legs that I'm plugging into the Pythagorean theorem, and I'm trying to solve for my hypotenuse. Once again, it doesn't look like we're going to have one of our triples here, because I end up with 41 equals c squared. And in that case, it's not a perfect square, and I cannot simplify it. So for kj, we end up with square root 41. Now I want to use this information to figure out my perimeter. So to find the perimeter of my triangle, I just need to add up all three sides. So we have 6 square root 29 plus square root 41. Now when I write it out like this, I cannot combine any of my terms. So what I'm going to do is change those two square roots into decimals. So for the square root of 29, I end up with 5.4. And for the square root of 41, I end up with 6.4. So now I can add up my three sides, which gives me 17.8 units. Now we need to figure out the area. So just to recall, my formula for the area of a triangle is 1/2 base times height. Now in this case, I'm going to treat HK as the base. Now if that's the base, I want to figure out what is the height of my triangle. So my height is going to come from the highest point straight down to the base and form a right angle. Now technically we already found the height when I sketched out my right triangles earlier for the Pythagorean theorem, and in this case it looks like my height is going to be 5. So I have my base, I have my height, now we just need to plug it into our formula. So it's going to be 1/2 6 times 5. Now once again, you're not distributing that half to both terms, you're just multiplying everything together. So if you want to, you can start with the 6 and 5. So then it's going to turn into 1/2 times 30, which will then give me 15 units squared.